in the design school, at least you should be able to design something, right? Draw something. So if you are in the computer science, even though I focus on a lot the theory or the data structure or the algorithm, if you cannot the code such an algorithm, nobody will believe what you understand, what your idea, okay? So I'd like to give you guys to practice such any program language is fine. However, if we are using the very new program language, please try to provide all the information from the required file or environment or any specific condition. Otherwise, if GA cannot compile, GA cannot run your program, it will be probably fail. So you need to provide all the proper information. Okay. So message passing, we need to create something. The method, in this case, is based on the message queue. It's a first in, first out, which means the process A, for example, it's a 0. So which means provide. First, message 0, message 1, message 2. Then process B is taking. Okay, it's kind of producer or consumer architecture. We will see such a processor and consumer architecture later. And in case of the shared memory method, we allocate the shared memory. So inside process segment, which means this one will be available only for process A. Okay? So the other process actually cannot access. That's not allowed. It's very, very critical to protect the information in the memory. Because memory itself is nothing but address, series of address. It's a very strict rule. The other process cannot access this one. So you need to give the proper permission. How to provide the permission? You need to check. Okay? If you want to implement such a way. That's one thing you should be careful. One of the students who implement this one, first time the struggle, do not have the permission, so but you can get. So we can understand such a communication as the producer and consumer problem, which means producer is the process, consumer is another process. Producer process provide the information, any data or message. Then consumer is listen, consume, read the data, takes the message. Okay, that's the basic way of understanding the interprocess communication. At that time, such a media in between producer and consumer, we can define the two types of the buffer. Okay. For example, message queue. If we are using the message queue, one is unbounded, unlimited. Okay, you can the push. You can send no matter what size of data you can push. But there's another one, bounded buffer. Okay, it's a fixed buffer size. So in case of the shared memory, shared data, so we can define the shared data as the size of the buffer. How many in, how many out, okay? How many messages are out, how many messages are in. It can be, in this case, the 1 byte will be one message, so it's a number of byte and number of byte. Then producer can be defined as this one, which means it's a until buffer full, okay? So you can put the data, so next to produce, okay? So that's the item next to produce. So you can put in the buffer, then increase it. And the consumer, you can take out, so you can out will be increased, okay? Then you can consume. So next consume. So in your, this is just the skeleton. So in your the interprocess communication implementation, you are going to follow you can follow the same architecture. So if you, in this case, it's the buffer is a shared memory. So if you want to implement a shared memory for the communication, you can define your shared memory like the struct. In your case, it's just a simple 0, 1, 2. So it's a 1 byte of the data, and also it can be the limited, the bounded buffer. So very simple, but depending on the data you need to send, you need to communicate with the other. So it can be the very complicated or the unbounded or something the struct. You can define such a struct over here. So each item is not just 1 byte of the data, it can be the structure. It's kind of the skeleton program for the process. And when you implement a shared memory, so you need to worry about the synchronization. What is a synchronization? Simple idea is, I'm always add up the data. Okay? He is always subtract the data. So plus 1, I'm doing plus 1. He's doing always minus 1. So there's a number, 5. So he did his job and I did his job. So what is the output of this? So 5 currently. So if I did my job, it will be 6, right? Plus 1. If he did job, it's 4 minus 1. So he did his job, I did my job 1 time for each. What will be the output?
5.
It can be 6, it can be 5, it can be 4. Right? So for example, I did my job and followed by him. It will be 5. He takes the 5, I take the 5, and he get back his job. It's a 4, but I put my job. It's a 6. And similarly, it can be 4. So we don't know what is the output. That's the synchronization problem. It's the same thing. But in our case, so you need to control in the main. Okay? You can control the main if we want to use the shared memory, but that will be discussed the details in the chapter, chapter 5 or 6. So anyway, process synchronization, we will see later. But in your program, if you want to use the shared memory, but if you believe there exists a synchronization problem, so it can be always 1 by 1. Okay, then you prevent such a synchronization problem. Okay. What about message passing? Okay. So we are going to use such a media. So in between the method, so that is the it can be message queue, it can be socket program. So at that time the media is like a packet. So we can use the packet. And we usually have a sender as the send message function. That doesn't mean we have always a SEND system code. No, it's kind of the skeleton program. So if you are using the socket, one should be the server, the other probably the main function will be server, and the children process will be the client. So send and receive. You need to have 2 functions. If you implement a bidirectional, each one should be send and receive, and the other send and receive, something like that. Then, when you are using such a message passing, you need to establish the communication link. This is a typical example, the circuit program. Okay. So 420, 415, 415?
Yeah.
We have 10 more minutes. So also, you need to determine whether this is the one direction or bi-direction. So you, in your warming up project, you need to decide whether you probably it's the bi-direction. But one direction can be doable. So it's up to you. This is I probably you maybe better than me for the programming. So when you solve the specific problem, do not try to solve the all at once. Okay? Just start from the simple problem. So, for example, I do not know how to create the process. Start from the creating process. There are a lot of references the manufacturer provided, and there are a lot of examples. And start from the creating process. If you successfully create, what about the two processes? Whether you can create the two processes. If you can do that, and add some additional function to your children process. Okay? It's not just a process, it's doing something like the printf. Okay? Okay? System out. Something like that. Then start separately you can start the communication. Just simple communication using whatever the method, and whether you can send the message and receive the message and display. Whether you can then later you can combine. So start do not. So many of the students just combine and ask, I don't know how to start. Then my answer is, I don't know how to help you. I really try. Start from the very simple problem. That's my suggestion. This is not the programming contest, definitely. So the GA has the different criteria for your programming. Okay. So this slide shows the different types of the implementation for the communication link. So we can use the shared memory, hardware bus, and network, and logically we can use like the buffering. Okay. I'm not going to accept using the global variable. Okay. Many of the students, because when I did not specify such a restriction, using Java program, just create the two classes. One is the master, and another one is the children, the class. Then I'll create the global variable. Then that's it. So there are different kinds of the communication. So first one is the direct communication, and another one is the indirect communication. Direct communication means just like the socket program. So and the client, they directly establish the communication link and send the data as a packet in this example. That is the direct communication. Okay. So for example, it has a P and Q are the processes, and they have to send the message and receive the message. At that time, you can specify the receiver, and also you can specify the sender. So if that one is matched, you can receive it. Otherwise, you cannot get the message. Okay. Otherwise, you can you can receive the message whoever that is, whoever the sender is. Okay. Indirect communication, there is another media, like the mailbox is one of the good examples. We have the mailbox, so each mailbox has the ID for each process. So you can leave the message to the specific mailbox. So he has his mailbox, he has his mailbox, he has his mailbox. If I want to communicate with that process him, then I can leave the message to his mailbox using ID. Okay, that is the indirect communication. Okay? It's up to you in your program. So you can either decide direct communication or indirect communication. So each mailbox has a unique ID for each process. So you can specify the who will receive the message. Okay? So this is a straightforward. So you can create the new mailbox, okay, with the coordinate and send or receive the mailbox and destroy the mailbox. It's obvious. And you can specify the receiver, okay? more pages. I hate the back-to-back class. So if usually my voice is a very high tone when I have a lecture. So sometimes it's shout. So most of the time at the end of the second class, it's almost exhausted. Okay, I will try to finish the couple of more. Okay, so I can synchronize the sender and receiver. So synchronous means you can actually specify. As I said, it's a synchronous and asynchronous. So you can specify sender and receiver. Then you can send and receive the message from and for the specific process. Otherwise, if you do not specify, you can send any process that is asynchronous. Okay? Sometimes we have the problem like this. So if the sender and the receiver is not matching, it's a blocking, so we cannot get the data. Okay. So from the buffering, so we will discuss. I think pretty much buffering I explained. So from the example, we will discuss in the next class. Next week we will have the discussion on the thread. Okay. So right now you can start for your warming up project. When is the due date? 15th. So today is the 5th. So you have enough time. Thank you.